Recordings in progress. Good evening, y'all. This is Platoon. Evenings and weekends. This is golf. We're on full stack. Week 11. Day one. We're 11 weeks into this bad boy. Getting up there. Getting old. Um, Running out of stuff to teach you. So we've spent the last 2 weeks doing SQL, which is a beloved tool. Everyone loves SQL and loves writing raw SQL. And you're probably thinking to yourself, oh boy, I sure hope the rest of the course we continue to write SQL. Wrong. We're not going to do that. We'll be doing other things. We'll be using operational object relational mappers, mapping, ORMs, things that do SQL for us. Because sometimes your database ain't always going to be SQL, huh? Maybe it's MySQL. Maybe it's Oracle. Maybe it's a million other things. Maybe it's SQLite. You got a development database that's different than your testing database, which is different for your production database. They all have different levels of data, and you need to map your objects to it regardless of what the database is. That's the real reason. The other reason is maybe you don't want to write raw SQL because SQL can't interpolate, right? SQL is just raw. You're not writing any SQL, craziness in there. You're not writing dry SQL. You're writing, SQL is the opposite of dry, truly. It's very verbose. So I know it says full stack. You probably thought we were getting into some full stack, but really, really today we're setting up two containers, a database and an API, and they're gonna kiss. But they're both gonna be deployed, and we've kind of done a little bit before, but we didn't have this operational object. I keep want to say operational risk management. It's not what it is, Jordan. Object relational mapping. That's what we're doing today. This is all going to build. It's all building. So this is like half stack today, but not tomorrow. All right. We're going to start things off by running the book publisher database. Have we used this already in the cohort? I forget. Anybody?
Yes, we have.
All right. I mean, I probably used it and forgot. On that on down. Cool beans. But don't just run away with it. It's got this setup.sh in here. So we're going to build, we're going to run, we're going to sleep, and then we're going to exec into it. That's not what we want to do.
No, that's not what we're gonna do.
We're going to start it up. Just run it. We're not going to go into it. But what's this? Can someone explain this line? I know Docker commands seem scary and big, but does anyone feel confident explaining
The
what's
way
going on here?
Homer kind of put it to us is you're exposing a port. So when that runs, it's going to expose a port on my local machine that's connected to my Docker when it creates that container. So its default port is 5432, but we're actually going to port into it with port 5444. Does that sound logical?
I think I misheard or you misspoke. We're not exposing our port, we're exposing the container's port.
Okay, yeah, I did
And
say that, but wrong. Okay.
And expose is a good word, I guess. What I really want to hear is port forwarding. When I
Oh, okay.
shoot, yep. So what does port forwarding mean? These two numbers.
Are you asking?
Yes.
Okay, you're basically taking the default port and you're forwarding it to a new port. So it's going to go from port 5444 to 5432. Isn't that?
Which port? Exactly. So which port, where does this exist? Which
It
port is
exists
this?
on 54. That's the forwarded. That's not the forwarded port. That's the, I don't know what you would call, because I want to say exposed port, but that's, I guess that's not the proper term.
What do we call a server that we're running on our own machine, not somewhere else?
Local. That's the
Exactly.
local port.
Yep. Localhost port, localhost, the port of the localhost. Anything that hits this port is going to go to this port on, where's this port located?
In Docker, our container.
Exactly, the container. That is correct. I mean, I think some of the answers are up here, but so we're gonna run it. This is gonna be the name of the container. Remove it if it fails. That can be handy. E is basically saying, what is E doing for us here? What is E doing for us? Because I felt like, oh, is it telling us to get us straight into this? I think this E needs to be over here. No, the D's over there. Yeah, what does E mean? What does soccer E dash?
I mean,
Goodness.
variable,
Say again?
environment variable.
Oh, yeah, that seems likely. Yeah, you're absolutely right. Because we are throwing an environment variable right there. All right, cool beans. Yep. So Docker run this image, what is built, or sorry, this is what it's going to be called when we run it. Looks TV. Yep. This is going to be the name of what we're running. The container we're going to run. There's just saying, hey, passwords, when I pass in, it's password, password's password. Port forward anything that hits my local machine at 5444. The container is 5432. The database's name is BooksDB. Not a big change here. The only difference is we're not going to sleep in an exec, and we're exposing that port forwarding. Everything else is about the same. Let's see what's going on with my Docker. Turn those off. Oops, Docker stop. Docker stop. There's a way to do both of those at the same time. Nothing running. Does anyone remember how to prune? Not Sean, you already answered.
Is it Docker images prune? Or is it pruned in images?
Don't think so, but I don't know if that'll do anything. Nah.
I think it's singular. Docker prune images. Right. Docker image prune is what I have written down.
Did I get it at all? I don't think they got it all. We need to figure out the difference. That'll be homework. What's the difference between Docker image prune and Docker system prune AF?
Yeah, I was getting ready to say because there's a few ways to prune. The system removes all the images and layers not in use.
Yeah. I think images or image prune is removing the ones that are built and not really in use right now, not running, and whereas Docker system prune is basically clean slate. There's no cached layers anywhere. We're getting rid of it all, which is what I want to do. Most of the time, you really, I'm not saying this is like proper Docker or whatever. You do what you want to do, but Jordan system prunes before he starts a new project. I don't want to pull down any old junk. I don't really see a downside of it other than costing yourself a little bit of time, but let's run this. So I'm running this setup.sh. It's going to build and it's going to run, and it should just leave it running unless there's some problem. Looks good. It's up. Should get nothing different there. Yep. All right. Nothing else running, just that. Once that is up, we are going to write queries against it using Python, not SQL. Here's a high-level diagram in case this is not explicit enough. We've got a Python application. It is going to send requests to the database. It is going to send results to the Python application. Seems straightforward to me. So if ever you're doing a pip install, anything whatsoever, you should be creating a Python environment. Do I have a handy one there? Oh, look, I got a super handy alias. When I type the word venv, it does all these things. I create a module called venv using the venv library. Then I source it, which activates it. So rather, I run this script here. So I can get away with just doing this. Creates it, slaps me right into it. Or, you could run these one after another and type them out like a fool. I like aliases though. Why would I ever type all that? Next, we're going to install PSCOPG2 PSGCOPGY2 binary. You need this specific one. You're going to run into a lot of issues as you try and pull the latest greatest, because it's gone past 2. This is what we're using for this course. This is what we'll be using because we don't want to get crazy into it and all the most modern junk. We're just proving that we can use Python syntax to interact with the database. So done. We got some notices. You could upgrade pip if you wanted. It's fine. You don't need to do that all the time. All right. So with your local virtual environment set up and your database container running, we've done both. We can now move on to the Python. Just to make sure everything's working, create a Python file and run it. Just copy this over here real quick and let's talk about it. Code, what does it want me to name it? I guess it doesn't really matter, but db_script. Remember, if you type the word code for something that doesn't exist, it just creates it. All right. This is a lot of hoopla that you've not seen before. But I don't like just pasting and telling you, I believe. But we do have to do that just a little bit. This is a library that exists. We could dig into this library and try and figure out what all these specific commands are and whatnot. By the way, it's not magic. In our virtual environment, in our bin, there's our activate script there. What about all these other libraries? Oh, hey, that's where that got installed. This wasn't here before when I pip installed. Man, that thunder is hitting. You probably can't hear it, but Squid can. Within my virtual environment, we got a library. There's a Python 3.13. Here's all our junk. If I really want to know what was going on with this stuff, there's all kinds of like documents and stuff within the virtual environment. This ain't a thing we just ignore. You do ignore it. Make sure it's in your git ignore. But here's docs on it. Here's actual Python code. It's all just Python within Python. Nothing crazy, nothing magic going on here. If I wanted to find this connect command, I bet you I could. We're not going to go into all that, but that's where these libraries are existing, right? We installed it. It gets put into this virtual environment, and Python knows all the Python commands, all the pip commands are coming from this virtual environment. We know that. Doing this, hey, look at that. What is Python 3? It is this one right here. And the binary within it, running Python 3 within the virtual environment. It's no longer my system Python. Don't want to get the global one dirty. This is the specific one here. It's fresh. It's brand new. Whatever I pip installed in it is there. You want to know what you pip installed? Pip freeze. That's everything in there. You want to save it. Type it out. Now you push this up. Anyone else that installs it, we all know requirements.txt, but we're going to keep hitting on this because some of you eventually are going to submit a test that doesn't have a requirements.txt and want to yell at you. So the way this works, we're using the PSY SOC. I'm going to call it SciCopG2 because that no one's, y'all got to deal with it. With SciCopG2.connect, and we can make some assumptions here because this stuff looks familiar. Host, localhost. Port 5444. Yep. Port on your machine. That will be forward request to 5432 in the container. Database is books. That's probably right, right? I mean, that's what we called it, didn't we? Oh, actually, we would have to check here. Yeah, it's called books. User Postgres, like usual, it's what our default's been. Password, that's been default. So this reads a little bit like a CSV reader. We're going to say with this tool as the connection, with the connection.cursor as cursor. Not very easy to read, but what this is saying is with this connection that you've made to this database, you're going to create a cursor. What is the cursor? It is this SQL command. Using that cursor, you're going to get everything that is retrieved from this. All this to avoid using SQL to type this one line right here, right? Seems like a lot of hoopla. Not really, but we have to tell Python about the database. When we've been using SQL, we've been creating the database, telling it what the database is, what's in there, everything going on, and then running it. It's still doing all of this. It just doesn't, it's not as configured, right? Python doesn't just assume it knows what database you're using. We have to specifically tell it, hey, go get this one. Ideally, this should just work. Hey, look at that. It worked. But it's cooler than that. We connected to our container, right? Our container that was running. Y'all agreed. You nodded your heads when I said I got a container running. This one here, that Postgres database. I connected to it via my localhost port. Again, Sean swore we were using 5444 to port forward to 5432 on that container. Reached in, got its database with the user, with the password. We authenticated super safely. No one will ever guess our password. And then we ran this command on it all through Python. Looks like a big pain in the butt. Why would you do that? Well, we mentioned this before, class. This library is generally used under the hood of a lot more easier to use ORMs. The Django ORM, which we'll be using, will look a little bit more Pythonic. If you ever use anything outside of Django, SQL Alchemy, Peewee are very popular libraries for interacting with databases. They look a lot more Pythonic. So this is the ugliest this could possibly be. If we were to do this in Peewee, it would basically, this would look kind of similar, but we wouldn't be using with. We would just specify, hey, this is the database, and the commands would be significantly more simple, like authors equal I think it's, yeah, it'd be like fetch. And that would just get them all, right? You don't need to say, hey, make a connection, use a cursor with the cursor. I need to execute a function, add this function in here. Why we're going through all this trouble to use an ORM, but we're still writing raw SQL. Who cares? And then you have to learn there's a different function on top of that function to call the function, to print some data out. This right here would create a variable that does the exact same thing. All this would go away. Again, if this was Peewee. And I'm not saying we're going to be using Peewee today. I'm just specifying if this looks like a bunch of crap, that's okay. This is the lower level of a lot of these other, things we teach. Should we just teach one of the others instead? Maybe, if I can convince the other instructors. They like this one. It's the most used library. So just bear with me for a bit. We're not going to be writing super ugly Python like this for interacting with databases for long. This is just for today and as we get through this module. But check it out. We got all the authors, all their information, and we didn't have to type a SQL file. There's no SQL file, being used here. This was used to create the database, but we're not querying with SQL. We're doing it with Python, even though we're cramming, SQL in there. It's still with Python. This is all Pythonic. You know what I could do that I couldn't do in Python, or sorry, just raw SQL? I can interpolate stuff, right? we could get away with this. We could do other things. We could put lists in here if we wanted to. We don't have to just force it to be, SQL. We've got the power of Python. We can interpolate. This is at least a reason you might want to do this. It's a little bit more expandable than SQL and to be built into a Python API. Makes sense. Also, I know you're looking at me like, well, that's silly, Jordan. That's a lot of extra work. Wrong. What is this? What does data mean right now? We just printed it. Not a trick question.
It's the data that was returned from the SQL query. So it looks like it's a list object. Yeah, it is.
Sure. Yeah, I
And-
just wanted you to say variable, but
Okay.
yes.
Okay.
It is a list object and it's got, stuff inside of it. So if this was SQL and I said, hey, I just want their first names, this would get a heck of a lot more complicated, right? Can we all agree? I wouldn't say this. I would have to be like, I want first name. I want first names equal to Julie or Casey or something like that. We gotta lean on SQL. But we already know Python. And it's in Python. This is just a Python list. We could do whatever we want with this data. So data exists right here. Why not, or whatever in data, print data. Let's not do this anymore. Let's run that. Ooh, we're actually iterating through this junk, aren't we? Or are we just spitting it out every time? Am I doing what I think I'm doing? Oh, there we go. Look at that. We're using Python to iterate through some SQL. We just use SQL to get it. Now we can use Python to futz with it. I don't know about y'all. I like this. I like what I'm looking at here a lot more than the SQL junk I've been doing, right? I've now got Python variables that I can work with. That's my first goal as a Python developer. Get it into Python as fast as you can and then play with it, right? I don't want to be using SQL to get all this junk if I don't have to. Pull into Python. Let's work with this stuff in Python. I only want, the first integer or the first, what do you call it, index of all these things. Check it out. I got that. Looks great. It's just Python now. This might be a little bit of work, but what's the payoff? It's Python. We got a Python API. This explains it a lot better than I did, but there's a reason I didn't want to explain it all because I don't think we need to retain all of this. But some of you like to learn everything. Create a cursor. This is a little abstract. It's a necessary step. Execute. We're passing in the SQL to the execute method. Fetch all. This is going to get all of them. Yes, it does seem odd. We already told it what we want to get. Well, now we need to tell it we want everything of everything we get. Don't worry about it. Docs suck. We're going to learn better tools. This is bare minimum Python to do what we want to do. As we looked at, we showed off we could use a little bit of Python to kind of work with this stuff. So if we want to do something with the results, hey, quit licking. Great for D and data. If D, the first, we got a list. This is the top 40, right? So this is what this is doing. If I told you, hey, I want SQL, I only want the first names, and I want the top 40 of them, limit 40. We could write that in SQL. But something we're doing here that I don't think we'd be able to do in SQL, not easily anyways. Notice the names here. How would you get the first name with just SQL? Anybody want to guess? Using all our SQL knowledge, how do we get the first name out of this?
Do you have to use, well, no, I will say some modulus somehow.
We're gonna do some weird stuff because that's just not the data that's in the database. It's got the whole thing. But Python, if I said, hey, I only want this first one, I bet we all figure that out pretty well, right? Let's just split on these spaces and just give you that first one. Easy peasy. Already making it easier. I mean, let's run this to make sure I'm not lying to you, but uh-oh, no results to fetch. Okay, well, I pasted that. Hold on. Oh, sorry, this wasn't the first 40. Any indexes greater than 40, so I only want all the indexes after the first 40 authors. Give me the first name. How do we split? Well, I want the index 1 after you split, or was this first names? Yeah, it doesn't matter. I don't want you to worry too much about what we're doing here outside of we were being returned these full names. It's in Python now. We can do Python things. Is it more efficient to use SQL to pull just the information we want? Absolutely. How efficient do we need it? Do I need it to run in a nanosecond or 3 nanoseconds? Does that matter? Maybe not. So if efficiency to that level is not important, this is what we can do. Does this make sense to everybody? Does anyone like the idea of using Python over SQL? If you can. Some of us might like SQL, and that's fine. Lots of good jobs with just SQL. But I like Python. All right. Jordan, telling us about Python. We're supposed to be doing full stack. Yes. We're going to do that now. We're going to make some quick changes, though, to how we stood this up, or how we're running this current Python script. Something you may not have known, or maybe you did. Here's my running container. I want to know more stuff about that container, though. Docker inspect. Hey, look at all this crap. We can see, you see a lot of junk here. One thing in particular that we need to know how to do. This script is running localhost, right? If I were to deploy this into a different container, would localhost really work anymore? If the database isn't running on that container? Like, the database is in a container. This script, this API, is in a container. What's localhost going to do for that?
Will you say that again, please?
Right now, this script, Python script, I haven't deployed. This isn't a container. This is running locally. I am port forwarding 5444 to 5432. That's great. Well, what if I containerize this API and it's now here? The database is in a different container. I'm not port forwarding this anymore. How do I tell it to go find that container?
When you say API, you mean the db_script.py?
Yes. It's our little API right now.
So if you container it, it's not going to be able to reach out to the port.
Well, not as localhost, right?
Right.
It's
got to have its own port to forward back to that container that's running.
You can do that.
Well, wait a minute, though. Wait a minute. But localhost is a network, and so that's always local. If you
Are my images running as local hosts though?
no, what I mean is that local host is always referring to one's own PC. Of course, if you cut off the access, it's not going to be able to find it.
I agree.
I mean, unless you move it to a different network or anywhere else, of course, it's not going to find it. But that local host, unless it's different on Windows, which I don't know, it's going to reference its own PC.
That's
And
right.
so, I mean,
We need a new IP, which you don't have to scroll through all this if you know what the name is. We could work through that. Instead, I'm going to do grep. Again, grep is just global regular expression. I'm saying, hey, the Docker inspect, print this out. I want you to find me the lines that match this word here. Oh, super easy. That's our IP we got to target. Let's hold on to that. Hey, it happens to be the same one. I wonder if there's a reason for that. Go to your VS Code window where you have dbscript.py, and at the same level, we're going to create us a Docker file. Seems straightforward enough. Let's try it. Do I want all this in here? Let's make, this isn't, you don't have to do this. Let's keep it clean though. I've got everything that's in this image, my database image. Let's pull everything else out. That's, our Python stuff. So currently this API directory is empty. Let's get our virtual environment in there. We don't really have to. We're not really going to use it again. Let's get our script into there. So this is the right one. Be careful doing stuff like this. If I were to move this over here, I could create a second one. You can very easily jack this up and have database script.py in 2 different locations, and you make updates to one, but you're not updating the one you think because there's actually 2 of them now. Just make sure you don't run into that problem like I run into when I was getting ready for this lecture. All right, so we know about this IP address. We're going to slap a Docker file here. Yeah, let's just do it the point and click way. What do we want to call this? Oh, yeah, Docker file.
does any container always have an IP address associated to it or no?
If it's running, yes.
Okay.
It's got to be running on something. It might, you can point the port at it, but it's got to be running. It's there. It's got its own. So this Docker file, we're pulling down a Python 311 cluster. You don't really need to worry too much about that, other than it's an image that's got a lot of cool Python tools. Working directory, sure, slap it in the source. We need a working directory. It doesn't really matter. Remember, we are using this library, so we need to make sure we pip install it. And we want this script to be up there, so we're going to copy our script over. Our command then will be Python space dbscript.py. That'll be the image. It's just going to be a container with scopg2 in our database script. Easy peasy. We just need to make sure that it can indeed talk to the other container. The change we're making here is not crazy. We're just changing the host. It's not localhost anymore. The other change is the port, because we're not port forwarding anymore. Oh, hey, comment. We're not port forwarding anymore. I'm telling you, go to that IP, that running container, and use the port that it has exposed, which is 5432. Get rid of all Jordan's crap. If that's the only thing that changed, truly. We know the host now. Your host might be different. And we know the port is going to change because we're not hitting that port forwarded port anymore. Let's build it and run it, huh? Where are we at? I'm in the API directory. Should be good to go. I'm just going to Docker build, tag it as a PG query dot. I should have paid for the beefier one. And it never comes to be a problem until we're doing Docker. Great. Who, without reading ahead, but you can kind of guess, I want y'all to explain it. What's going to happen when I run this and why? Danielle.
You don't have any of the arguments.
What arguments? So you're talking about these, right? These things.
Yes,
Why don't I have to put those down here? Or well, maybe I do. Why do you? What if I didn't have to put them down there? Why do you think I don't need those anymore?
because you're not forwarding a port, so you don't need the port section anymore.
Well, I don't need that, true. But think about so we were just trying to run against, well, right. This is setting up the container, right? But this is telling that container all the things it needs to get into that database. BooksDB, there's the port we need, there's the password, you know, we know localhost, whatever. We're starting up this image. When we start up this image, we're going to run this script. What's this script already got in there?
It has the port and all that stuff in it already.
Yeah, exactly. So we're just going to run it and run that script. We don't need to do anything special. It's just going to run, and hopefully the script connects properly. I think it will. Who knows? Stuff always breaks down in front of y'all, though. There we go. All right, cool. I ran it. A lot of hoopla to print out a few commands here, or just, get a few of these. And we did this earlier locally. But what are we doing now? Start to finish, what's the full stack here? Jonathan, I ran this command right here. Why am I seeing these names?
Because in the
Cradle
script,
to grave.
because in the script you requested it.
All right, you're gonna have to draw more lines than that. What is this doing right here?
It's running. Where's the thing? It's running your cursor execute data equals print the variable that we created. All that stuff.
Back up more. What is this? What's PG query?
PG query. That's
Yeah.
the.
I'll help you out a little bit. Will I? I'm not gonna help you out at all. We ran it here. So what's PG query?
It's the image, right?
Exactly, it's the image. So when we tell it to run that, you said it runs the script. How does it know to run the script?
Because we told it to.
Where?
Inside with the cursor as cursor data equals all that stuff. No.
Nope. You jumped to
I'm jumping all. Yeah, the Docker file.
yes. So we created an image out of this Docker file and we told it to run this. So when we say Docker run, it's going to run this tagged image that we built. When we built it, we said, hey, this is the command you run. Now you can go ahead. So this runs, what does that run here? What's that doing?
tells it to run it in Python, run the file, and then the script file, and all that
Mhm.
stuff.
Yep. Keep going. Cradle to grave. What are we doing in this script?
So with our SciCop G2, we're going to connect on port 17217, or that IP address on port 5432
Yes.
in our books database as user Postgres with our password. And then we're saying, hey, go get me this data that I'm asking for.
Yeah. Yeah. But I want, yeah, a bunch of hoopla to do this, right?
Yeah.
And then we don't need to, break this down, but truly it's, hey, for every instance you've got, get me the first thing when you split the name, give me the everything after the 40. There's like 11 of them or something, whatever this is. So that's what it's doing. But it's important that we understand how this is getting us this and why that's important, why it's different than just running it locally. Because what we've done is we've set up two containers that are agnostic of each other. They don't know about each other at all. And we're telling it, hey, you need to go get a database. Where's that database? It doesn't know it's a container. It could be a server. It doesn't matter. It really doesn't matter. All it knows is it's going to go connect to some database on some port and some host. It does not know that thing's a container. It doesn't know it's on its network. It doesn't even know if it exists, but it's going to go try. And that's the real difference here. We're not just saying, hey, I got something locally, go find it. Like, these are two containers that could exist in completely different, areas. As long as it's on your network and it's got an IP, it can see, we can hit each other's containers. It's get a little different. You try to hit each other's containers across networks because you're not on the same network, so we're not going to be able to do that. But if we were in the Co-Platoon office, we could probably do that. We're not going to check with all that.
George,
Cool. What? Yeah,
so
what's up?
the Docker container, it makes an IP address dynamically. So that means that the Python file IP address is going to be hard coded, which would always mean it's after the fact.
This is not the most scalable thing, right? Because if I set up a few other containers, that host might change.
Well,
This is not this is in general a bad build, right? Because we're making some assumptions. Those assumptions are that Docker container is always running on this host.
yeah, because I was trying to understand, like, okay, on the networking side, Docker must be making this dynamically, since it always has to have a IP address. So I was
Correct. If we were to start up other containers, we would have to sift through that and make sure we find the right container.
okay.
I believe they're just going to iterate past this too. This is usually the first one that's stood up. Docker just does that. But you're right. Figuring out dynamically what that's going to be so it always connects to whatever database you stood up, not really feasible. What's important here is it's two different services. That's a keyword we'll use later, that are connecting to each other. This does talk about, where do we get into this? We'll use Docker Compose later to manage this, right? Notice the pains that occurred here. I had to build and then run a database in a container manually, and then I had to build and run a Python API manually, and I had to tell them about each other apart from each other. Like they're not on the same file, doesn't exist, right? If I go and change something on my database container and change it, like, and update it, my Python side is now broken, right? These are two different directories. If I make a change in this one, it's not going to be updated here. Docker Compose is something we'll get into. We'll be specifying these things in the single file. So if I update the database image, we're going to know about that in our API. Docker Compose is going to allow us to deploy a bunch of services all at once. So I don't have to build one and then publish it, and then run it, and then build one and then run it, then build another one and run it, or do it. It's going to set up services on its own, all in one file. We'll have a Docker Compose.yaml. As we all know, YAML is the best configuration language. Y'all think you like JSON? You don't. Promise you don't. Not for configuration, you don't. It's good for data. All right. Starting to get opinionated. That means I've been opinionated this whole lecture, but it means it's time to end the lecture. Do we have any questions?
I guess I would like to know exactly what all we should be able to do with that. It seems like a little vague yet to me. Does that make sense? Like you
What?
explained it all, but I don't know what I'm going to be able to just go do with that on my own yet.
Well, you could step through this lecture and have two containers running and talking to each other. From there, if you want to create your own database, your simple database, Dockerize it and run a query, well, you could probably just use this as a, bones. This right here is basically everything I needed to create a database and containerize it, right? I got a Docker file that sets up the Postgres database and copies my init.sql into it and runs it. And then I've got examples of how to create a database. So you could, you don't need this many of them, but you could, create your own database. And if you so choose, a setup.sh file to kind of get that running. So this would, once it's set up, once you keep it simple, right? Don't build a giant database. Let's just get something simple going on. Just something that you run, it builds your database and puts it in a container and it's running. Once that's done, you should be able, man, I really hit forward too many times, to set up scopg just like this. This, for the most part, is all going to be the same. You just need to make sure your ports, if you choose different port, is right. Your database name might be different, but these things could probably all be the same. And then just run a query. It doesn't really matter. Just pull them all, select them, get them. Show that you can get some Python to go get some stuff, and you can iterate through it, play with it, no problem, right? Once that's done, I've given you the knowledge to get the IP from that running container. Then just update your Python script with that new host IP. Make sure we're using the port that we exposed in our database. So is this where it's done? Yep, here it is. Make sure it's this one and not the forwarded port. Make sure it's the port that we're running the database on. So the database containers port. And just build that sucker and run it.
To answer your question simply, Kim, I think what this is going to do is, how we've been putting Docker run all the information, password, and all that stuff, the port number and everything. Once you set it up, just like as Jordan said, all you have to do is Docker run in the image name. It'll create a container and return the data with your print statements. So you're seeing your print statements in your terminal at that point. So you can kind of see it's more of a simple terminal command, and you're telling it through Python what you want returned versus through SQL queries. Does that kind of sum it up, Jordan?
No, you forgot this part. Okay, you forgot this part. But we didn't tap on that part. So yes, Docker run is saving us from running, all that jazz when we run a query. But we did that here. I just used Python. I wrote Python dbscript.py, and it hit our port forwarded port and hit that container. That was done locally, right? If you get this far, this is just Python contacting a containerized SQL database. The next step was pushing that into its own image, and they're still talking to each other. I know it's just a run. It runs that and then dies. But that's the real other piece. At this point of the lecture, we proved we could use Python to contact a SQL database and iterate through it. And at this point of the lecture, we have put that in a container and shown that it still works. And I'm only overemphasizing it because I want to make sure we're all on the same page. Does that answer your question, Kim, or did I go way off the rails?
I probably have more questions, but I don't know if I want to do it on a recorded session.
No, it's okay. Because I want to hammer on this a lot, because this is not something that just I expect someone to read the first time and just get it. I'm being loud and animated about it because it is important that we understand all the beats here. It's different than running this locally and running Python, right? That's not what we're doing. We're containerizing a database, which we've done before. That's not the new part necessarily. But we are interacting with Python to talk to SQL, which is a new thing. And while we're at it, containerize that, and they still should be able to talk. And the only change is how it's connecting to that database. That database is running on this port on its local host. And we were saying, hey, when I hit my local, or when I hit my port, I want you to go to that port. We're taking that out of the equation and saying, hey, go to that IP and hit that port. And I'm doing my hands like this to make sure there's two containers, but I want to make sure we consider that these are running images and they're not connected to our local host at this point. I just started up, ran it, it killed itself, did its thing, donezo. It's
The two programs based on this example is PG_query. That's one
Mhm.
Dockerized. The other one is books_DB. That's the other Dockerized image.
yes.
So when you're saying you're getting two to work together, it's those two images. One's getting containerized, running whatever to talk to the other DB image, grab the data, spit it out on your machine.
Yes, and then it ends because it has nothing else to do. If we
Right.
wanted these both to stay there, we'll get into that. But if I really wanted to just stay there, I could I don't know, I could tell it to run this query, wait 15 seconds and run again and just make it, they would sit and keep talking to each other, and then there'd be a live thing, and then maybe we could talk to that API. But that's outside of it. It's a triangle. And we're at two pieces of the triangle. I've got an API and a database. We will never again talk to this database past today, ideally. We are going to talk to this API to talk to that database, because this is the way. Full stack, we're not going to be writing raw SQL anymore. That API is going to be the only way we talk to this database. So the triangle is generally like front end hits API, hits database, goes back to the API, comes back to the front end.
API being that PG_query image
Yes,
that we just
and-
created. Yeah, I think that's where I was getting lost, is like, what two programs? What are you talking about? Oh, it's
right. I know. It's
program.
just, it says
that
it's a
program.
script. It's an API that exists for about a nanosecond. It doesn't stay alive. But if it did, what we could do is we could run it and leave it running, and then we could start making commands. So when I ran Python scikout G2 here, I ran a Python script and I hit that running container. All we would do is, instead of hitting that original database container, we're now going to start hitting that API instead. We will get to that point once that API is stood up and existing and has useful stuff to do, that's the next step. Right now, it's running once, dying, it's done. What it's going to look like is database is going to stay up like it currently is, right? I've got my database is still up and running. But we're also going to keep this this one alive. And instead of, saying, hey, Python, run and go hit that database, we're going to say, hey, Python or, JavaScript, go hit that Python code. It's going to talk to the database for me, because talking to a database with JavaScript is heretical and you shouldn't do that, even though those libraries exist. I don't want to see that. It's called Prism, if you must. Sorry for not explaining that step of the puzzle. I understand now why when I said the word API, I got funny looks. Seem good? If you can walk through the lecture and do as I did, which I do encourage y'all to do, and as we get a little bit further, I think it's paramount to just, if you're not doing the lecture while I'm doing the lecture, which you don't have to listen while I'm talking, but like go back through the lecture on your own and make sure you can do that. Because if you can do the lecture, you're ready for the challenges. Just make sure you're able to blast through it. I know I've been talking for longer than I thought. But if I were to just copy paste these and explain to myself what they were doing without a class here, this would take me 5 minutes. And I think it could take you 5 minutes as well. Ensure you're able to do this. Ensure you understand the beats. And then change it, right? Instead of standing up that books database, just build your own. And all that is changing the init.sql file. Create your own database. We have done this before. If you whip past that, which if you want to just play with this and not move on to this more difficult crap, that's fine, because this is going to do what I want you to learn today. But if you want to get crazy with it and get back into assessment 2, you could very easily take your Python code, and instead of writing to CSV, maybe we use scicop G2 to write to a SQL database. I don't expect anyone to get to that tonight, but man, if you do that, it'd be sick, because that's what we'll be doing later.
Jordan,
Yes.
assessment 2?
Yep.
But we use SQL in assessment 2?
You used
We use CSVs.
We did.
CSVs.
Okay. Oh, we use CSV. Okay.
Yeah, just come down from corporate. We don't want CSVs. We want database now.
Okay, cool.
I think it's a smaller lift than y'all might think it is. But I'm excellent at Python, so that's it's really not that big a deal, truly. All y'all have to change, well, you have to create the database first, but then you're just changing your CSV calls to scicop G2 calls and interact with the database. You just got to build the database first. That's the part that you won't get to this in time, but anyways. All right.